It has actually been a greater demand from the students that I look at a question that talks about or tests on series and sequence. And of course, under series and sequence, we have two very important areas that can get introduced to you as a student by your teacher. And these areas are GP and AP. Good. So let's go ahead. We have geometric progression and arithmetic progression. And of course, a progression means a continuation. There is a proceeding. There's that aspect of having a particular arrangement continuing, you see, to get presented. If they are actually objects, they actually end up getting written down or arranged, and that creates a particular type of continuation. And we mostly always have to associate this with what you call a series. You see, you are actually, for example, in mathematics, coming up with digits, numbers, or numerals using a particular rule. You can decide to say, for example, I'm going to have 1, 3, 9, 27, 81. So this is a progression. There is a continuation in terms of the arrangement of these numerals or these numbers. And this progression forms a series. And this series of numbers only exists because of a particular rule. And which rule can actually govern the writing down of these numbers? One, we shall actually notice that moving from one number to another demands that we pick the previous number, then we multiply by what? 3. For example, I can decide to come here and take 81, then I divide by 27. That gives me a particular ratio. And that ratio is 3. So whenever there's a series of numbers in a particular question, and that series ends up having a relationship existing between those numbers in terms of a common ratio, then that type of series or that type of progression is called geometric progression. So a geometric progression or a GP has first the first term labeled as A. So in any geometric progression, the first term is A. And in this case here, because this is a geometric progression and this is a GP, then that means our A is 1, the first value to appear in that sequence, in that series. Okay, so the first sequence we have actually given here has the first value or the first term as 1. So this is our first term, and in any alphabetical arrangement in terms of the letters we have, the first letter to always appear in that is A. So A is also picked as the first term in any sequence in as far as geometric progression is concerned. And apart from having the first term as 1 or A in terms of its identity, we always have what you call R. And R is what we refer to as the common ratio. Then how do I get the common ratio? I pick that value that appears next, then I divide by that value that previously appears. For example, I picked 81 as my next term in terms of that writing, then I divided by the previous term, which is 27, and that gave me a ratio of 3. So in terms of a geometric progression, another thing to consider is a common ratio, which is given now in this case as 3. So getting any nth term in any common ratio that has a value like 3 and having any sequence as a geometric sequence, you're supposed to always say AR raised to n minus 1. This is a formula of getting the nth term. Nth term. That means the 10th value, the 13th value, the 26th value, the 100th value, the 27th value, the 5th value, the 13th value, the 29th value. So the nth term, the 98th value. So getting any nth term or nth value in a geometric sequence demands the use of a r raised to n minus 1. A times r raised to n minus 1. For example, if I want to get the nth term here, so this is the first term, this is the second term, this is the third term, this is the fourth, this is the fifth. So I want to get the sixth term. I know I can just say 81 times 3. Then I'm going to get my answer as 243. But mathematically, there must be a formula, there must be a procedure, there must be a stepwise working that gives you now the final answer, that makes you to arrive at the final answer. And that demand that you're going now to actually pick this as our formula to use in this case. So you're going to have a as the first term, which is 1, multiplied by r, our common ratio, which is 3, then raised to n. N, the nth. Which term are you looking for? The sixth, because you have 1, 2, 3, 4, 5, 6. So the sixth, so 6 minus 1. So this translates into 1 times 3 raised to 5. And of course, this gives us 243. That is how you can be able to get the nth term of a particular sequence if it is geometric in nature, having the first term and a common ratio. Okay, that is just a brief summary of the geometric progression. But I want us to actually look at something else in terms of what you call the arithmetic sequence. So with an AP, I can have 2, 4, 6, 8, 10, 12, then the progression has to actually get seen. So if I want to actually have this as my very important sequence to talk about, I'm going again to have A as 2. As usual, the first term is 2. Then here, we do not have a common ratio. We have what we call the common difference. So D is our common difference. So if someone talks about ratio, there must be a division. There must be the number, whatever has to actually go into that number, and then the quotient or the answer. But in terms of the arithmetic progression or the arithmetic sequence, there must be something called a common difference. Of course, difference means you're supposed to get the difference between 2 or more values. So the difference between any of those 2 values can give us the common difference. Subtraction will totally get captured in our discussion. So I can just say 12 less 10. That gives us 2. So our common difference is 2. Our common difference is 2. So if I decide to get the nth term of this arithmetic progression, so I'm going to have this a plus d into n minus 1. Okay, so our first term is 2. I know the answer here must be 14, because it is 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 2, 10, 10 plus 2, 12, 12 plus 2, 14. But how do I use the formula to first be able to get the same answer? I'll say the first term is 2 plus, then d is the common difference. Our common difference is 2 as well, so 2 into n, the number of terms. So you're getting there. So first, second, third, fourth, fifth, sixth, then seventh. So you're getting the 7th term, so 7 minus 1. So that is 2 plus 2 into 6. Okay, so how do you get 6? 7 minus 1. So 2 plus 2 times 6, that is 12. So our answer is 14. Our answer is 14. So in terms of getting this summation or this sum of these terms of this GP, you see, how do I get the sum of these terms of this geometric progression? And again, how do I get the sum of these terms of this geometric progression? So in terms of getting the sum, you need to know this. So sum, if an arrangement is a geometric progression, should be so sum of n terms. right, should be equal to a into r raised to n minus 1, then everything is over r minus 1. So this is the formula of getting the sum of a particular number of terms of a geometric progression if r is greater than 1. So if r is greater than 1, then we shall say the sum of n number of terms of a geometric progression should be equal to a into r raised to n minus 1 over r minus 1. But if r is less than 1, then the formula of getting the sum of any terms of a geometric progression should be equal to a into 1 minus r raised to n, close the brackets, over 1 minus r. Correct. So this is the formula of getting the sum of n terms of a geometric progression if r, or the common ratio, is less than 1. And here, if r, or the common ratio, is greater than 1. Yeah, I'm just giving a brief summary, then get to the question I was supposed to have actually worked for you today. And if the arrangement is an AP, an arithmetic progression, how do I get the sum? It only has one formula. So sum is equals to n over 2 into 2a plus d into n minus 1. I think you can be able to see. So this is when you want to get the sum of an arithmetic progression, and of course it does not have more than one formula, because you only have what you call the common difference. And once you have the common difference, you can just be able to say the sum of n terms of an arithmetic sequence should be equal to n over 2 into 2a plus d into n minus 1. N stands for the number of terms, a stands for the first term, d stands for the common difference, n stands for the number of terms. In this case here, a stands for the first term, r stands for the common ratio, n stands for the number of terms, r stands for the common ratio. In this other case, a is the first term, r the common ratio, n the number of terms, r the common ratio. So that is just a brief summary of the geometric progression and then the arithmetic progression in terms of what you have as the Pearson Edexcel type of curriculum and the Cambridge Igcse. And if we get to the question now, you are actually told that the third, fifth, and eighth terms of an AP corresponds to the first three terms of a GP. If the common difference of the AP is 3, find the first term of the GP. So we are told that the third, fifth, and eighth. So we are here. We are told the third, fifth, and eighth. Let me just put this down. So the third, fifth, and eighth terms of an AP can form the first three consecutive terms of a GP. Okay, so we are here. So this will form the first, second, and third. So you're told the third of the AP, the fifth of the AP, and the eighth of the AP will form the first, second, and third, the first three consecutive terms of the GP. So we need to come up with expressions representing those terms given in the two different types of sequences. So I know very well, how do we get the nth term of an AP? I said a plus d into n minus 1. How do you get the nth term of a GP? A r raised to n minus 1. So can we come up with expressions? The third of the AP, we can put here 3. We do not know the A, we do not know the D. So we can just put here 3. So we shall have A plus, then 3 minus 1, that is 2. 2 times D, that is 2D. Okay. Then let's come to the fifth. So we shall put here 5. We don't know A, we don't know D, but we know N is 5. So we shall have A plus, then 5 minus 1, that is 4. 4 times D, that is 4D. Okay, let's come to the eighth. We shall say a plus, we shall put here 8. So 8 minus 1, that is 7. 7 times d, that is 7d. So the third term is a plus 2d, of course, for the AP. The fifth term is a plus 4d, and the eighth term is a plus 7d. So these are the three expressions representing the third, the fifth, and the eighth terms of the arithmetic progression. But these three can correspond to the first three terms of the geometric progression. We shall actually be able to get the first term. We shall put here 1. So the first term of this, the first term, so the first, we shall put here 1. So we shall have just a. Why? Because 1 minus 1, that is 0. So r raised to 0, that is just 1. Because anything raised to 0 is actually 1. Mathematically, in terms of the laws of indices. And when you come here, we can put here 2. So we shall have ar raised to 2 minus 1, that is 1. So we shall have ar, of course, raised to 1. Then if we actually look at the third term, we shall put here 3. So we're going to have ar, then 3 minus 1, that is what? 2. So ar raised to 2. So let's look at this. We shall be able now to have this. The third corresponds to the first. The fifth corresponds to the second. And the eighth corresponds to the third. But you're told that the common difference of this AP, the difference is 3. The common difference is 3. So what do we do next? We shall just come here and be able to know that. How do you get the common ratio? We said you can pick this first term over the second, or the second over the third, or you can decide to say the third over the second, or the second over the first. And because these are the same as this, we can actually be able to use this to get the first term, because you have the common difference. Then whatever you are going to get here can help us get these values, because we do not have any information concerning the geometric progression. We've just been told the third, fifth, and eighth terms of the AP correspond to the first three of the GP. Nothing concerning the GP has actually been given to help us get the values in terms of the A and the R of the GP. So we can be able to use this, and because they're actually the same, once you have these values here, they should correspond to the values under the geometric progression. So, how? We know very well. This over this can give us the common ratio. This over this can give us the common ratio. It must be the same thing. This over this and this over this. So I'll come here and say a plus 7d over a plus 4d. They are the same. So this and this must be the same as this and this. So this over this must give us this over this, because the values are the same. You see? And this over this must be equal to this over this, because the values are the same. So that must be equal to a plus 4d over a plus 2d. Then you can cross multiply. So we shall have a times a, that is a squared, plus a times 2d, 2da, then plus 7d times a, that is 7da, plus 7d times 2d, that is 14d squared. And this must be equal to, okay, let's come to this. A times a, that is a squared, then a times 4da, that is 4da, then 4d times a, that is 4da, then 4d times 4d, 16d squared. Correct. So a squared and a squared will disappear. Then 2da plus 7da, that is 9da plus 14d squared, should be equal to 4da plus 4da, that is 8da plus 16d squared. We can further collect the like terms. We shall take this on this side. So 9da minus 8da, then plus 14d squared. We shall take this on this other side, minus 16d squared. That answer must be equal to 0. Okay, let's proceed. We shall have dA, then minus 2d squared should be equal to 0. Okay, correct. Then we can factor out d, so we shall have d into a minus 2d. That should be able to actually end up giving us 0. So d times a, dA, d times 2d squared. Okay, so we have d into a minus 2d to be equal to 0. So that means d can be 0, okay, or a minus 2d is equal to 0. Very good. So we have this, and this cannot even give us anything because d is equals to 0, cannot even just give us any information in it in this question. So we are told that d is 3. We can't ignore that information. So we can just come here and say a minus 2 into 3 should be equal to 0. So a minus 6 should be equal to 0. So a is equals to 0 plus 6. So that means a is equals to 6. What was the question asking? The question is asking for the first term of the GP. It's asking for the first term of the GP. The first term of the GP, a. So we know very well this is a should be equal to a plus 2d. The first term of the GPA can only be obtained by saying a plus 2d of the AP. So a of the AP is 6 plus 2 into d of the AP, that is 3. That should give us a. So the first term of the AP is 6 plus 6. So the first term of the GP is going to be 12. So that is what you are supposed to have gotten as your answer in as far as this question is concerned.